Energy is power. It is capacity to do work. Then you may ask, what is work then? Well, work in science is the form of energy transfer. In science, in particular, energy is actually called the ability to do work. And there are all forms of energies. Now, if you are having this file and I require you to go over these two videos about all forms of energy. There are different forms of energy, right? Or different way of doing work, or light energy and electrical energy. Mechanical energy is how things move and raise to a certain height, that is mechanical energy, and also the nuclear energy and potential energy. They're all forms of energy. I try not to take too much video space, so I encourage you, or actually require you, to watch these two videos if you have this file, and also different energy of different forms. Work. You use this word in your daily life very often, but that is definitely related to the work in the science sense. So in physics or science, work is the product of applied force and the parallel distance through which the force acts, which means force times distance. For example, if this person is pushing this box with a force in that direction and move certain distance, and then it does work. And say if this is 25 meters, and if he used the word 10 newtons, 25 meters times 10 newtons, and will be 250 joules. So Newton times meter equal joules. So unit of work, force times distance, and it gives you joules. See, just think about the person. And if you have a stronger force and move same distance, you have a strong force, strong work, or more work. Or you have a force and move larger distance, you also do more work. Therefore, it is naturally, and this force times distance is actually how much work is done. And we said the work is the process of energy transfer. So which energy is transferred to which? So in this case, the person's in her body kinetic energy or chemical energy is transferred to this kinetic energy or heat when there is friction to this box. So in this process, the chemical energy and turn into mechanical energy, or eventually turn into thermal energy. So that process is the work. So work is the process of energy transfer. And notice the work has to have a displacement in the direction of the force. Okay, they have a direction relation. Okay, so if there is a force, a ground pushing the feet up, but the movement is perpendicular to it, there is no work because it has to be parallel. And also, and in this case, there's work. So she lifts up the flowers or vegetables, but then the movement in the same direction. Here, there's work. Also, once she lifts, then there's a force on her body on this box, but the movement is perpendicular to it and is not parallel. Therefore, this force does no work. So, has to be in the direction of the force. You may ask, so how about this force and the distance in a very random angle? In that case, which we will not talk about in this class, but then if you are interested, is multiply with the trig function cosine. Okay, remember cosine of 0 degree, if this is 1, so which means in this case it's 100%. The cosine of 90 degree is 0. So, and then of course in any other angle, you simply apply a percentage, cosine equal to a number that's less than 1, which means that's the percentage of the force that being applied into direction of motion, and then that just gives you how much work is done. So work is force times distance. So units of work, once again, is joule. And also encourage you to watch this video, or you're required to watch this video. We have been talking about work and energy. Now we take a quick sidebar, talk about the gravitational force, or it's a review. We have already talked about this. Now, weight. What is weight? Is the gravitational force on the Earth put on an object. So, which means how much weight is it? So now in the last chapter, we talk about the acceleration. We know for the fact that any object will accelerate down with the 9 meter per second square acceleration. So if you let go of a tennis ball or anything, let go, it will have this acceleration. So then let's see what force that will be on it. So then we apply the Newton's second law in this. So if you know the mass, right, and then if you know the acceleration, mass times acceleration, get you the force. Therefore, what is the gravitational force? Because we sort of use the Newton's first law and the other way. Okay, usually you will calculate, you give the force, give the mass, then you will calculate the acceleration. Now we know the acceleration. If we know the mass, and then what is the force? We simply F equal ma. This is a very common form of writing Newton's second law, which is simply multiplication away, and there's another form of Newton's second law. Now, so if you have 1 kilogram object, for example, and then it will accelerate at 9.8 meter per second squared, and then kilogram times the acceleration, gravity acceleration, then equal to gravitational force. Remember, the gravitational force, not any force. Not any force will be mass times 9.8. That's force. So the force is 9.8 newtons. How much is it? That's for 1 kilogram object. So this is 1 kilogram, 9.8 newtons, and then there will be 9.8 newtons. Anything on the Earth's surface will experience the force is mass times g. So mass times g give you the gravitational force. G here is 9.8. So now, if you take the object to another planet, it will probably weigh differently, which means the gravitational force will be differently, because that planet has a different mass, and then attract the object with a stronger or weaker force. As we will talk about this later, the gravitational force depends on the mass of two objects. Therefore, it's between the mass in your hands and the mass of the planet, or mass of the Earth. So if you go to another planet, like on the moon, onto the Jupiter, or maybe you travel to Mars, the planets is a huge ball, but the mass is different from Earth. Then they will have a different attractive force. Therefore, the gravitational force, the weight, is different. Usually, however, since we mostly stay on Earth, we always multiply the same number, g m 9.2 to the mass, calculate the weight. Therefore, the word kilogram it's equal to 9.8 newtons, and informal weight units. Once again, so this part is typical confusion, because it feels like 1 kilogram. Actually, it feels like 9.8 newtons, because in here we always multiply this number, and then therefore, of course, it's proportional to its mass. The gravitational force is proportional to the mass, and only this constant away. Therefore, these two words are kind of interchangeable. So becomes informal weight units. So kilogram be informal, but actually 9.8 newtons. But still, remember, weight is the gravitational force on the object, while mass represents the inertia of the object, how strongly the object resists motion. Okay, and they are conceptually different. All right, work. We talk about how to calculate the weight, the gravitational force. Now let's back to how to calculate the work done by gravitational force. Once again, work is force times distance. Now in this case, the gravitational force is in a vertical direction, which means up or down. So it's related to the object's height. So now let's look at this particular question. How much work is needed to take a 1.5 kg book out of the bag and move it from the floor to the tabletop? Basically, you pick up a book, pick from the floor and lift up in 3 meters from the floor. So on the floor and move it up to the table. How much work is it? First, what is the force? The force is actually the weight of the book and mass times acceleration, and then that's 1.5 kilogram times 9.8. That gives you the 14.7 newtons, which is the gravitational force on the book. And actually the force by your hand is actually cancels this force, so it goes up. Therefore your force does the work with the same force, okay, with the same force, 14.7 newtons. So that's the force, okay, downwards. And then this force is needed to move the book upward. And then calculate the work. Now we know the force, 14, and what's the distance? It's going up, and so there's 3 meters. So therefore 14.7 times 3, you get 44 joules. So let me draw a quick picture. Let me draw a quick picture. Right, so here we have a book at the bottom, right? So then the gravitational force is mass times g. So mg, which we got 14. And your hands actually cancel this and give your force, cancels it, but it's same magnitude but in opposite direction. Okay, and this force from your hand goes up the distance. I'm drawing with my mouse. So that's 3 meters. So then you do the work, and then the book goes up to here. Alright, so in fact we will see next, actually when you do work, your energy from your body turns into its potential energy. So therefore the work is energy transfer. So 44.1 joules of work is from your body through doing this work and transfer its potential energy, so higher potential energy here. So that has 44 potential energy. We'll talk about that's the next topic on next slide. Potential energy, like that book we talked about in previous slide. And if you lift up high your arm, push it up against gravity, so you do work, and then it stay at a higher position, like 3 meters above the ground on the table, but it's not moving. It doesn't have kinetic energy, but its energy is stored between the earth and the book. That's her potential. The potential to have kinetic energy. If you push it off the edge of the table, and then it will drop, which means it will gain kinetic energy. And then that's why we say it possesses some energy in the form of potential. Potential energy is energy in store, and the book on the table has potential energy relative to the ground. So if you push it off the edge, and then the gravitational force actually does work, and then the book is accelerating, and in that case we say the potential energy is transformed to its kinetic energy. Once again, when you push the book off the edge, its potential energy at that height and transform to its kinetic energy. And when it reaches the floor, and then it doesn't have any height, the potential energy reduced to zero. It's completely released, and then it has the highest speed, that potential energy, all transformed into kinetic energy. Okay, in general, not just gravity can have defined potential energy. There was anything that has a spring or elastic or ball or something can have defined potential energy. Potential energy is actually energy in store. It's not in motion, and then it can be released. So therefore, potential energy is formally defined the energy of an object due to the position or the arrangement of particles in the system. Okay, in the system. Now, go back to Earth and the object, the system. The potential energy is defined as, if you say the ground is 0, is equal to mass times gravity times the height. In fact, you probably noticed that's the work you have done to raise the book. If you do the work to raise the book, go this much distance, you have to do this much work, but the energy is not gone. The energy is transferred from your body. The chemical energy goes to the potential energy. So the potential energy has this much height. So gravitational potential energy in particular, and that's this case, is due to gravitational attraction. Okay? And now we have this simple question. What is the potential energy of 7 kilogram bowling ball 10 meters above ground? Okay, you have potential energy just because you have a distance from the ground. So it's easy. mgh, that's your potential energy. So mg, that's the gravitational force. 7 kilogram, 9.8, that's the weight or gravity times the distance. So that's the potential in 10 meters, so therefore 686 joules. And actually that's its dimension, kilogram meter per second squared, and actually this unit is actually, instead of writing this down, and you call that units joules. Now we have talked about two forms of energy already, kinetic energy and potential energy. Potential energy, you can watch these two videos, and you are required to watch these two videos about potential energy and kinetic energy. Once again, potential energy, the ability to do work, okay, and potential energy, the energy of the object due to the position and arrangement of particles in a system. In particular, the gravitational potential energy relates to the height from the ground. So mass times g times height. So look at this pendulum. So you swing back and forth. To interpret this, is when in a higher position, it has higher potential energy. When it stops, there's no kinetic energy. And then we go down, the potential energy released when it's at the lowest spot. And if you say that's 0, but then they have the highest speed at lowest point. So there's kinetic energy. So this pendulum is a good example of the energy conservation, kinetic and potential, kinetic, potential, kinetic, and potential. So then what is the kinetic energy? The energy due to motion. Yeah, the word kinetic basically means all motion. Okay, can be measured in two different ways. Okay, energy required to put an object in motion. Okay, and that depends on its speed, of course. The higher speed you want the object to move, the higher energy is required. Okay, and also obviously it's an increasing function, which means the energy required to move an object to a certain speed is proportional to the velocity squared. So the higher velocity, the higher the kinetic energy. That's really not counterintuitive. It's matched with your daily experience. So, but in particular, it's a half mv squared. That's the kinetic energy. So now we have if energy is the potential to do work, and good thing is that energy is conserved, which means the total energy or never disappear. The energy can never be destroyed or created, but it can transfer from one place to another or transform to one form to another. Look at this little train here. So let's see, the lowest spot is 0. So high or potential energy, low. When it goes fast, it have kinetic energy. Now watch. So this is the bar for potential energy. This is the bar for kinetic energy. So now you see, when it goes high, the potential energy is high. So when it goes low, kinetic energy. So go high potential energy, high in kinetic energy, and so on. But in any case, if there's no friction along this, which means the total mechanical energy is not transformed to thermal energy, so it's just between this potential and kinetic energy, the mechanical energy of this train is a constant, in the sense that is the blue bar and the green bar always add up to the same height. Because one goes up, the other one goes down. One goes up, the other one goes down. Okay, the other one goes up, this one goes down. So you see, their total just all add up. So that's the energy conservation law in action. All right, we talk about potential energy and the kinetic energy and law of energy conservation. Now let's review some exercise we did in class just to retouch these topics. We actually did it over and over again. So conceptual questions, this is actually in your class handout. What is work? And it will say a process of energy transfer. But if you say, well, it's force times distance, and you're right, it is how you calculate work. That's in the sense of science. Okay, it's the process of energy transfer because there is different form of work and different type of energy, but in general, it's always a process of energy transfer. Okay, and what is energy in your own words? Well, you will say, some students say, it's the power to do work, or it's the capacity to perform. Yeah, you wake up in the morning, you say, I don't have energy to go to school, or I don't have energy to prepare for my test, I don't have energy to go to the ball game, and so on. So that's the performance, the school, the study are the type of work. And the energy and the capacity or the motivation or the power or the capacity are the form of energy, right? So the power to do work. And if you look up in the dictionary, what is the work in the science sense? This is ability to do work. And so energy and work has the same units. So energy is the process of it, and the work is energy energy transfer. Okay, excuse me. How do you calculate the work done by a force? Then force times distance, they must be in the same direction, they must be parallel. Okay, if it's not parallel, you have to multiply the cosine between them. Okay, and cosine of the angle between them. Okay, number 4. How are work and energy related? The work is the process of energy transfer or transform. We talked about that already. So what is kinetic energy? We just said about this. Is energy related to motion? And obviously, motion you characterize by speed and velocities. How do you calculate the kinetic energy of an object? In half mv squared. Okay, and then how do you calculate the momentum? Just give you a pop quiz. It's m times v, not v squared. And also v with a vector. So momentum is a vector, which means it has magnitude and direction. But kinetic energy is not. It's a scalar, which only have a magnitude. Okay. What is potential energy? Potential energy is due to the object position or arrangement between objects. So it's like a rubber band or a spring or something stretched, or especially between the Earth and any object, you lift it high, actually the distance between the Earth and the object become larger. So then that is potential energy due to the position or arrangement of object. In particular, how do you calculate the gravitational potential energy as mgh? So, well, here we have some more problems to solve, and in fact we have done this in class. This is exactly the same slides from the class. Then there is a better version file called Solution to the Exercise Problems on the Moodle link. If you want to look at the details, or you can look at it. And in fact, we have a quiz exactly on these 4 questions, of course, with different numbers. Important is to understand the concept, understand the physics and the science about it. So, a force of 200 Newton is needed to push a table across a level classroom floor for 3 meters. How much work is done? And this is easy. Force times the distance. 200 newtons from here and 3 meters, so 600 Newton meters. It's called joules. And number 9 is a little bit harder. So 500 joules of work is used to raise a 102 kilogram crate to a shelf in a warehouse. How high was the crate raised? Or we could say in another way, say here the crate with something as 102 kilograms, right? That's the mass. And I say, well, I just have this much power. How can I lift it up? It's like saying I have this much gas, how far I can drive. Okay, it's like I have this much power, how I can drive. Then you realize that the force times distance is the power. So now the same relation we use the reversely, kind of reversely. So now force times distance, then that's the 102 times 9.8 here is 999 newtons. That's the force times the distance, and by that distance we don't know yet. Then in fact that's what you are asked to find out, but you write this in the equation anyway. So force times the distance, which is the force times distance. Force we know, and that's gravitational force, and times it equals 500 joules. So here's the equation, okay? And let me write down here. So this is a equal sign. So 999 times h equals 5,000. How do you solve h? And h is actually equal to this 5,000 divided by this. And then you get something like 5 meters, right? So, which means the answer is you're going to raise 5 meters. You don't have to remember this, okay? But sort of that's the answer. So in other words, 5 meters times this distance times the force, and they give you 5,000 joules. So, and there's a better version in the file called exercise solution and answers. You can look at it detail. Important is to learn the method, not just remember the answer, because it will be different numbers, but the equations and the concept is exactly the same, but not the numbers. All right, number 10. Calculate the kinetic energy of a 3 kilogram object traveling in a speed of 5 meters per second. And kinetic energy is the energy due to motion and due to the speed. And in fact, it is equal to half times mass times velocity squared. And then we will have answers in our, so you can do this by your heart. So it's half, so it's half. Now I'm writing with my left hand. Okay, and mass is 3. And then 5 is the speed, how fast it is moving. Okay, and squared. So now give me a quick answer. Okay, 5 times 5, you're right. 25 meters. 25. And 25 times 3, quick. And 25 times 75. 75 divided by 2, 37.5. So 37.5. Point out if I get it wrong. What? Joules. So that's the kinetic energy due to the motion of this. And of course, I can only write with the mouse, so I cannot write with pen, so it will be difficult to do this. All right, so now the last one, number 11, we talk about the potential energy. Potential energy is energy due to position or arrangement of objects. And you can have, but in particular, gravitational potential energy is mgh. So gravitational potential energy, potential energy due to gravity is equal to, okay, mass times gravity times g. Okay, in this case, all right, I will let you do the calculation, but important to remember the formula. So mass is 5. Okay, g is always 9.8 if you are on the Earth's surface. If you go to the moon, this g will be different, much smaller. But if you go to Jupiter or other planet, it will be bigger. Okay, so 10 meters, so 10. So then, what is that? So then, let me do using my calculator. Okay, so I'm pressing my calculator. 5 times 9.8 times 10. Okay, 5 times 9.8 times 10. Okay, 490. So if you get 490, congratulations. If not, let me know. 490. Okay, what is that? Joules. So, which means if you lift something with 10 meters, 5 kilograms, it has 10 joules. Okay, it has 495 joules.